Okay, this is concept 19, solving a matrix equation. Our first equation here, we have a matrix plus x equals another matrix. We're asked to solve the equation, in other words, get x by itself. So essentially we're just going to subtract this first matrix from both sides. So let's show that subtraction here. And we'll go ahead and say that that's not on this side anymore. So the result of this 2 by 2 matrix minus the other one is going to be a 2 by 2 matrix. A negative 5 minus 1 is negative 6. A 4 minus a negative 7 is 11. 1 minus 1 is 0. And 5 minus a negative 6 is 11. So x would equal this matrix on the right. For number 2, we've got a matrix times x equals another matrix, and we need to solve that. Well, we'd like to divide both sides of the equation by this matrix on the left, but we don't know how to divide matrices. But we do know how to multiply by their inverses. So we're going to find the inverse of the matrix on the left. And I'm going to do this on a calculator this time. Find the inverse of the matrix on the left and multiply that by the matrix on the right. That will isolate x and give us the resultant matrix, 40 and negative 9. And that's our solution for x this time. A little 2 by 1 matrix. Any questions on these first two problems? Okay, concept 20, we're going to solve these systems of equations. All we're going to do, the quick way since we have a calculator, is just put these in as matrices in our calculator and run the reduced row echelon form function on the matrix, and answers will appear. So we'll get 4, negative 4, and 0 for the first system, and we'll get 1, 4, and 2 for the second system. You can check these, just plug them in, make sure they work before you go on. Any questions here? Okay, for concept 21, on number 5, we're going to find a quadratic model for the set of values. In other words, we need to find a quadratic equation, the equation of a parabola that goes through all three of these points. So we have the given points, we just need to come up with the equation. We should realize that the equation will look something like ax squared plus bx plus c equals y, or y equals ax squared plus bx plus c if you want to go that direction. Using this information, we can just substitute the values for x and y into the equation 3 different times and create a system that we can solve using our calculator. So putting negative 2 in for x, we get negative 2 squared is 4. That gives me 4a. Putting negative 2 in for x gives me negative 2 times b is negative 2b. The c is there, and y is 13 for the first point. So all we've done is put negative 2 into all the x's here and 13 into the y and written the equation. Now we're going to do the same thing with the next point. 0 goes in for x, and in for x that zeroes out these first two terms. I have c is equal to the y value is negative 3. So this one doesn't give me a whole lot for an equation, but it does give me important information. And finally, the last point, put 4 in for x. 4 squared is 16, so I have a 16a. 4 times b, 4b, plus c is equal to 13. I'm going to go ahead and plug this in my calculator as a matrix, and then run reduced row echelon form on it. Find out that a is 2, b is negative 4, and c is negative 3. So my equation, my model, is y equals 2x squared minus 4x minus 3. This is the equation of a parabola that will contain all three of the given points. Any questions here? Okay, for number 6, we need to graph the parabola. Y equals negative quantity x minus 3 squared plus 3. This parabola happens to be in vertex form, so we should be able to look at it and pick out the vertex here. The vertex is going to be 3, 3. I also need to find x-intercepts, if they exist, and a y-intercept, so that I can graph. I can tell by looking at this value in front of the squared term that this parabola is going to open down, so that's going to kind of guide my thinking as I go. X-intercepts occur when y is 0, so I'll be doing some math stuff for that, and the y-intercept occurs when x is 0. Let's see what happens when x is 0 here. When x is 0, this term would be 0 minus 3 squared. Negative 3 squared is 9. So I'd have negative 9 plus 3 would be negative 6 would be my y-intercept. Now I have to do the part that requires a little bit more effort here. I have to find the x-intercepts. The x-intercepts occur when y is 0. So I'm going to let the 0 go in for the y and solve for x. I'm going to go ahead and add this term to the other side and square root both sides to solve for x. All I'm trying to do is get x by itself here. So x minus 3 is equal to positive or negative root 3. And if I add the 3 to the other side, x equals 3 plus or minus root 3. So those are my intercepts. One of them is 3 plus root 3, and the other one is 3 minus root 3. Root 3 is about 1.7, so this intercept would be pretty close to 4.7, and this intercept would be pretty close to 1.3. Let's go ahead and graph. My vertex is at 3, 3. Plot that point. My y-intercept is at 0, negative 6. This is negative 5. Negative 6 is about right here. And then we'll go plot at 1.3, 0, and at 4.7, 0. And then go ahead and sketch our parabola. Not a very good drawing with the pen here, but we get the idea. Any other questions here? Okay, concept 22. We're going to do number 7, factor the expression completely. I noticed some good things happen here. I've got a perfect square in the front. I've got a perfect square in the back. If this fits the pattern, I can factor this quickly. The square root of 5x squared is 5x. The square root of 9 is 3. If I multiply these two terms together, I get 15x, and if I double it, I get 30. So that's good. This does fit the pattern of a perfect square trinomial. So the factorization would be 5x plus 3 times itself, or 5x plus 3 quantities squared. That one's done. Number 8, it looks like I have a difference of two squares. 4x squared is a perfect square, and 25 is a perfect square. So I can factor that using the difference of squares pattern. I have a 2x plus 5. The 2x comes from the square root of 4x squared. 5 comes from the square root of the 25, and a 2x minus 5. And I have two solutions for these problems. Any questions on either of these problems? Okay, our last concept here, 23. Number 9, we have to factor completely. I don't see any perfect squares in the back this time, so I'm going to go ahead and just factor. I do notice a 1 here, though, a 1x squared, so this should factor with the simpler method. So we'll go ahead and check. Let's see, can I find two numbers that multiply to make 28 but add to make 11? Well, I'm thinking 1 and 28, 2 and 14, 7 and 4. There we go, 7 and 4. We'll do that. They multiply to make 28 but add to make 11. So let's go ahead and set this up. I know I need x's in the front of both binomials. That's the only way when I multiply it back out I'm going to get an x squared. I need the 4 and the 7 to be in the rear of the binomials. That's the only way when I multiply it out I'm going to get a 28 here. The signs have to be the same. The only way to get a positive 28 is to multiply two negatives or two positives. And in this case, we need two positives because we need those to add up to positive 11. So there's my solution for number 9. Looking on to number 10, we have a perfect square in the front but not in the back. So I can't use any shortcuts on that. I don't see any number that I could take out of 4, 49, and 90. So I've just got to do some brute force mathematics here. I've got to calculate AC. AC is 360. That's the 4 times the 90. I have to find B. B is 49. And now comes where all the work is. I just have to figure out two numbers that multiply to 360 but add to 49. After some effort, I found 40 and 9. 40 times 9 is 360, but 40 plus 9 is 49. With those two numbers, I can go ahead and set up my little area model and find the factorization here. There's my area model. We will put the first term that we're working on in the first box. We'll put the last term that we're working on in the last box. And then remember the 49x gets split into these two values, a 40x and a 9x. That's the same as my 49x. Now I look down the first column. I ask myself, what can I factor out of a 40x squared and a 40x? Well, I can take out a 4 and an x. I look across the first row. I ask myself, what can I take out of a 4x squared and a 9x? I can take out an x. Now I'm trying to fill this hole. 4x times what is 40x? Well, that would be 10. Now I'm trying to fill this hole. X times what is 9x? That would be 9. So I have two factors here. I have a 4x plus 9, everything's positive, times an x plus 10. If I FOIL this out, I'm going to get what I started with, so I know this is the right answer. Any questions on 9 or 10? Okay, the last problem on this exam, we're given the function that models the height y in feet of a stone t seconds after it's dropped from the edge of a vertical cliff. How long will it take the stone to hit the ground? So we're looking for how long will it take the stone to hit the ground. Round to the nearest hundredth of a second. Well, when it hits the ground, it's going to be 0 feet high. So that would be the y value at the time we were interested in. So when y is 0 feet, it's basically saying what's the time it takes for that to happen. So let's go ahead and solve. If I add this negative 16t squared to both sides, I'd have a positive 16t squared on the right. I'm going to go ahead and divide by 16. 586 divided by 16 is 36.625, and then take a square root. And I get the positive or negative square root of 6.05 seconds. Well, negative time doesn't make sense, so we're going to just get rid of that, keep the positive. So my solution is 6.05 seconds. That is rounded to the nearest hundredth. Any questions here?